In this lesson, we are going to learn about complex numbers. Now, when we say a complex number, another word we can use would be imaginary number. So what we're dealing with in this lesson is going to be the square roots of negative numbers. So we're going to work with the square roots of negative numbers, and we're going to learn how to add and subtract with them. We're going to learn also how to multiply and divide with them, as well as how to raise them to different powers. All right, so as we begin, we need to understand a few basic definitions. So first off, we have what is called the imaginary unit. And this imaginary unit is represented by the letter I. So I for imaginary. And I is equal to the square root of -1. So this is crucial to understand because our entire study of complex numbers will begin with this basic understanding. So make sure you have this memorized. So we have what's called an imaginary number, which is a number that has a square root of a negative number. So for example, if we have a, which is equal to a positive real number, then the square root of -a, which is equal to I times the square root of a, that would be an imaginary number. So right here, if you have something like this, where you have a square root of a negative number, that would be imaginary. And what we can do is we can pull out the imaginary component, which is the letter I. We'll explain that a little more in detail in a moment. So then we have our definition of complex number. So a complex number is going to be something in this format where you have a plus bi, where a and b are real numbers, and then I is equal to the square root of -1. And with this, a would be considered the real part, and b, the coefficient with I, is the imaginary part. All right, so what does this look like? So let's take a look at the parts of a complex number. So we're going to go through a few examples here where we have some expression, and we are to find the real part and the imaginary part. So here we have 2 minus 4i as our first example. The real part would be this 2, and the imaginary part would be the -4 that is with the letter I, because I is imaginary. So if you had -3 plus 7i, the real part would be -3, and the imaginary part would be this +7 in front of the letter I. Now what if you just had the number 3? Well, 3, you can think of this as 3 plus 0i. So 3 would be the real part, and 0 would be the imaginary part. Now what about -5 times I? This you can maybe think of as 0 minus 5i. So here we can see clearly that the real part would be the 0, and the imaginary part would be the -5 that is in front of the letter I. Now let's move on and discuss standard form. So here we have an example. We have 5 plus the square root of -32. Now standard form would be basically pulling out this negative inside of the radical and writing this with the letter I somehow. And then also make sure we simplify the radical as well by pulling out any numbers that we can. All right, so here what we can do is we can think of the square root of -32 as the square root of -1 times the square root of 32. Right, and the square root of -1, as we stated, is our basic definition, and that is going to be the letter I. So what we have is I times the square root of 32. And the square root of 32 we can simplify. We can break that down. That would be 2 times 16, or 16 times 2. We can separate that to get square root of 16 times the square root of 2, and the square root of 16 is 4. So we have 4 times the square root of 2. So our answer would be I times 4 times the square root of 2, and typically we put the letter or the number 4 in front of I, so we have 4 times I times the square root of 2. So this here, and actually don't forget we have the 5 in the front. So we have 5 plus this. So this would be our expression written in standard form. So the imaginary part, we would write it in this format where we have the real number or the rational number out in front, the I would come after, and then the radical would come at the end. And the reason for that is because the I, if we put over here, so if we had like the square root of 2 times I, it's maybe difficult to tell if that is equal to that, or if you have 2 and the I on the inside of the radical. All right, because those are not equal, those are different. So to avoid confusion, we put the I in the front, as you see over here. And we see all of that typed up right here. Let's try another example. Here we have the square root of -4 minus 12. All right, so first off, we can simplify this square root of -4, and we can think of that as the square root of -1 times the square root of 4, and the square root of -1 is I. So we have I times the square root of 4. Square root of 4 is 2. So we have I times 2, which is 2I, and then minus 12. So we have this expression, and to put it into standard form, we need the real number first. So the -12 should come first, and then the imaginary part would come second. So in standard form, you would write this as -12 plus 2I. All right, so that would be your final answer. And we see that typed up right here. All right, so again, the key is pulling out the imaginary component. So our goal is we don't want to have to write out every time the steps, the square root of -1 times square root of 4. You can just come to the conclusion that we can pull out the imaginary part by putting an I in the front, and then we write the square root of +4. All right, so then from there we can go to get I times 2, which is equal to 2I. All right, so eventually you can get proficient at this, and you can do a lot of this in your head. If it's helpful, you can show the steps, but it's not necessary. So now that we have some basic definitions out of the way, let's now discuss different operations with imaginary numbers. So to begin, we're going to talk about adding and subtracting. So when you're adding and subtracting, it's really just like adding and subtracting with variables. All right, so here we see in math notation the property of addition, and it's kind of confusing maybe to look at, but basically we add the real parts, so a plus c we put together, and then we add the imaginary parts, bi and di. We add those together to get b plus d times I. All right, and same idea for subtraction. All right, so if we have a minus sign connecting, so we have a plus bi minus c plus di. All right, what we do is we take a minus the c, put those together, that's the real component, and then plus, so plus because of that plus sign there, plus, and then bi minus di. So we do b minus d, and then put the I out at the end. All right, so that's maybe confusing with all letters. Let's try an actual example with numbers. Here we have 3 plus 7i plus 12 minus 4i. So we can add this just like we would with regular numbers and variables. We can add 3 plus 12 to get 15, and then we add 7i plus -4i to get 3i. So our answer in standard form would be 15 plus 3i. And then subtraction is the same kind of thing. So here we have 3 plus 7i minus 12 minus 4i. So we do 3 minus 12. That would give you -9. And then plus, we have 7i minus -4i, which becomes a plus 4i. 7 plus 4i is 11i. So our answer, written in standard form, would be -9 plus 11i. And again, standard form is when you have the real part first and the imaginary part coming second. So we have addition and subtraction. And next we're going to actually talk about the powers of I. because we need to discuss that when dealing with the multiplication and division. So here we mentioned I is equal to the square root of negative 1, right? So I equals the square root of negative 1. Or you can think of that as I to the first power equals the square root of negative 1. All right, so now from here, what if you squared I? Well, what that means is that you're squaring the square root of negative 1. And when you square a square root, that cancels out, and you're left with just a number on the inside, which would be negative 1. So when you square an imaginary number, we actually now have a real number. So I squared would be negative 1. We can take this further, I to the third power, and the way to think of this is we can write that as I squared times I. I squared, we said, was negative 1, so we have negative 1 times I, which is negative I. So I to the third power you can think of as negative I. And then I to the fourth power, we can think of this as I squared times I squared. I squared, we said, was negative 1, so we have negative 1 times negative 1, which equals positive 1. So I to the fourth power would be positive 1. Now what if we tried I to the fifth power? All right, so we'd have I to the fourth power times I. I to the fourth power was 1, so we have 1 times I, which is equal to I. So I to the fifth power is equal to I. So notice at this point that I to the fifth power is the same thing as I to the first power. And what we're going to find is if we keep this pattern going, if we do I to the sixth power, seventh power, etc., all these values are going to repeat. So I to the fifth power is equal to I to the first power. I to the sixth power would be the same as I squared, which is negative 1. I to the seventh power would be the same as I cubed, which is negative I. I to the eighth power is the same as I to the fourth power, which is 1, and etc. So this pattern is going to continue. We have I, negative 1, negative I, 1. I, negative 1, negative I, 1. So it repeats. So what we can do is we can use this to figure out I to any power. So if we're trying to figure out I to some large power, what we do is we have to divide by 4. So we divide by 4 because it repeats after every 4 numbers, and then we see what the remainder is. So whatever the remainder is, that's going to be your new exponent. So for example, if we had I to the 49th power, okay, so we could go through, the really long way and just keep listing out over and over again. But the short way is we take the exponent of 49 and divide by 4. And 49 divided by 4, that gives you 12 with the remainder of 1. And so this remainder right here of 1, that becomes our new exponent. So now we have I to the first power, and I to the first power is equal to I. All right, so that's the process, and we can do that for any exponent. All right, so make sure you understand how the powers of I work, and especially make sure you understand that I squared is negative 1. The reason is because when you're multiplying and dividing, you're going to see that come up over and over again. So now let's talk about multiplication of complex numbers. So we're going to look at 2 examples, and the first one, we have 2i times 4 minus 8i. Now when you multiply, it's basically the same thing as you would do with variables and with regular numbers. The only difference is at the end, when you are simplifying, we have to take into account that I is the square root of negative 1. So what does this look like? Well, let's try distributing. So we have 2i times 4, which gives you 8i. And then 2i times negative 8i would give you negative 16i squared. So if this were just regular variables and numbers, we would just leave it like this. But in this case, we need to simplify. And I squared, remember we said I squared is negative 1. So we saw that in the last slide. So because that's negative 1, what we have is 8i minus 16 times negative 1. Negative 16 times negative 1 is positive 16. So we have 8i plus 16. And then make sure we write this in standard form, where we write the real part first and the imaginary part second. And that gives us our answer of 16 plus 8i. Now let's try another example. Here we have 7 minus 2i times 4 plus 2i. So again, we can distribute like normal to begin with. So we do 7 times 4 to get 28. 7 times 2i would give you 14i. And then we would have to distribute negative 2i to both terms. So that would give you negative 8i and negative 4i squared. All right, so now from here we can simplify. So we have 28, and then 14i minus 8i would give you 6i. And then here, negative 4i squared. Remember, I squared is negative 1. So we have negative 4 times negative 1. And negative 4 times negative 1 is plus 4. So we have 28 plus 4, which is 32. And then you add that with 6i. So your final answer in standard form is 32 plus 6i. Now to finish off this lesson, we are going to discuss division of complex numbers. And with division, our goal is we need to get rid of all the radicals in the denominator. And remember, we said I is a radical, right? I is the square root of negative 1. So when we are dividing, we must simplify such that there are no i's in the denominator. So for example, here we have 5 over 2i. And the standard way of writing this is, again, we cannot have a radical in the denominator. So we need to get rid of the letter I in the bottom. So to do this, we would take the same approach as we would with any other radical, and that is by multiplying the numerator and denominator by some value. In this case, we only have one term, so you can multiply top and bottom by the letter I. So in the numerator, we would have 5i. The denominator would be 2i squared. And remember, I squared is negative 1. So we have 2 times negative 1, which is negative 2. So our answer is going to be negative 5 over 2 times I. And we actually probably should write this with the I on the outside. So we have negative 5 over 2 times I. And the negative should be, I guess, just anywhere, but it could be on the side. It's probably the best way to put it. And that's what I was trying to do. But here we have a negative on the outside. So we have negative 5 over 2 times I. All right, let's take a look at one more example. And here is an example where you have a binomial in the denominator. So again, we need to get rid of the letter I in the denominator because that is a radical. So what we can do is we can, in this case, multiply the numerator and denominator by the conjugate. So the conjugate is when you have a binomial, such as 3 plus 4i, and you switch the sign in the middle. So instead of 3 plus 4i, now we're going to multiply top and bottom by 3 minus 4i. All right, so we do that on the top and the bottom, and we have to FOIL in both situations. So here in the numerator, the first terms would give you negative 12, and then the outer would give you positive 16i. And then we can multiply the inner terms, 10i times 3, that gives you 30i. And then the last 10i times negative 4i, that gives you negative 40i squared. And then we can simplify that in a moment. And the denominator, we have 3 plus 4i times 3 minus 4i. And when you're multiplying conjugates, when one is plus, one is minus, we can do the shortcut where you multiply the first terms, 3 times 3, and the last terms, 4i times negative 4i, which is negative 16i squared. And we see that all typed up right here. So to finish this off, the numerator, we could combine 16i and 30i. That gives you 46i. So we have negative 12 plus 46i. And then here we have negative 40 times I squared. I squared is negative 1. So we have negative 40 times negative 1, which becomes a plus 40. So we have negative 12 plus 40, which is 28 on the top, plus the 46i. All right, so that's your numerator. The denominator, we have 9 minus 16i squared. Again, I squared is negative 1. So we have negative 16 times negative 1, which is positive 16. So 9 plus 16 gives you 25. So this would be our answer, but we want to write in standard form, which we'll put up here. So we have to separate into two fractions. We have 28 over 25 plus, and then we have 46 over 25. And the I, that's in the numerator, we can pull it out here on the side instead. So our answer in standard form would be 28 over 25 plus 46 over 25 times I. And that concludes our lesson for today. We will see you next time.